I chose to speak about this topic because two experiences. So one is that currently at work we are using Databricks. But then again, it is what do you call this? So yeah, we are using Databricks. So supposedly, what do you call this? Because we are using a common platform, it should actually be easy to what do you call this? Um, uh to transfer work, right? To transfer like for example, like right now I'm coming into the middle of the project, so it should be easy for me because we're using the same platform. We have like what do you call this? We have Git and all those things. We have wikis and stuff. It should be easy to actually get the code running, right? Like the one that is being transferred to me by another data scientist because that data scientist will be transferred to another project. So, but the experience is not that, right? So, what do you call this? So, like I've spent a lot of time just trying to figure out why the code is not working, and then at the end of the day, the code is not working because it was ran or it was being developed in a different what do you call this, in a different development environment than I was using. So they were actually using what do you call this, a version of Databricks that is like what do you call this, like 13 point something in terms of LTS. But then I thought, but then I usually I work or I use the most recent version of the of Databricks. So it's weird. So and then so that's one experience. The other experience is that when I was working for a startup, what do you call this? I was the first data scientist that they hired. So I was surrounded by a lot of software engineering people or developers. So, but the developers, they're using a different language. So I think they're using Rails, Ruby on Rails at that time. So, but I don't know how to use, or I don't know how to use Ruby on Rails. So essentially, the language that I prefer to actually use is R. And so, what do you call this? And so we were wondering, like, how are we going to what do you call this? How are we going to integrate the data science models into the software that they are developing? So what they've done actually is what do you call this? They created for me an environment, so like a development an environment wherein they do not necessarily care what language I am using within that development environment. The only thing that was requested from me is that I should expose those models, or they will expose those models, um, what do you call this, in within the software. So like, but it has to be called through APIs, and then what do you call this? Data will be coming in as JSON files or JSON string, and then I should give the prediction to them also as a JSON string, and then it goes through what do you call this? Um, it goes through the different databases that it needs to go through. So what I really like about that situation was that in my 17 years or almost 18 years of experience doing data science, that was the only time that it was so easy for me as a data scientist to actually deploy my models. I can change it whenever I want to change it. I can incorporate whatever packages that I wanted to incorporate. I can make it as complex as I want or as simple as I want, as long as what do you call this? As long as it will take as input a JSON string, and then it will give an output also as a JSON string. I don't need to bother anyone. I just needed to I can do the development. The only thing that, what do you call this, that sort of stops me is that it has to go through QA. So the QA will actually test it, and then if it tests, then he will deploy, the QA team will deploy it into production. If it doesn't pass, usually it doesn't. I haven't had, what do you call this, I haven't had a deployment that it passed on its first on the first try. Usually they would have to return to me because it failed some edge case that they were testing, and so I would needed to consider those edge cases as well. So yeah, so that is the two stories. So that's why I think that containers, especially if you don't necessarily um, if you're in a team that who don't necessarily program in the same language, can be very useful. Okay, and I guess the most popular one is Docker for containers. Okay, so we'll go through the installation of Docker because it can be a challenge. So when I was trying to learn how to do this, what do you call this? It actually took me like 12 hours of going through like different videos or going through like different YouTube videos or going through like blogs and stuff like that, asking Chat GPT or Copilot why this is not working. So hopefully, and that was just an installation of Docker. So hopefully by going through this, you don't have to go through the pain that I experienced when installing Docker. So you can watch. So I've attached the YouTube. I'll share this presentation later. You have the on top. You have the YouTube video that I found like was really very helpful for me. Um, and then what do you call this? And then also the docs.docker link is basically the official documentation on how to install Docker. So the first thing that you need to do, or that Docker will require, is that you need to install the Windows subsystem for Linux. So that's the first step. So what you need to do, so but it's sort of easy to install it. So what you can do is that you can run a PowerShell, a Windows PowerShell as an administrator. You want to install this as an administrator. And then usually the Windows system will have WSL or Windows Subsystem for Linux already within the distribution. So all you need to do is just type WSL dash dash install, and then it will go through the installation. And then after that, you restart your computer. That's it. That's sort of easy. But you call this, but usually when you try to install Docker, right, like at least the what do you call this? The first instance that happens is that you try to install the Docker package or the Docker software, but that's not it. So if you install it first without installing this, it will not work. Now, the next one is you need to verify your system requirements. So you should be able, or not, because again, once you install Docker, what do you call this? It will require some system requirements from your laptop. So what you need to do, or the most current version of Docker, you need to have Windows 10 64-bit Enterprise or Pro or Education version, and it should be a 22H, what do you call this? A 22H2 version, or a Windows 11 64-bit, whether it's Enterprise Pro or Education, and then the version of it should be 23H2 or higher. So how are you able to find that? What you can do is that you can go to the search toolbar on the bottom of like, wait, we can demonstrate that. So what you can do is, oh wait, let's use this. Um, wait, where's Oh, wait, there. So what you can do is that you can just system, you can do this, and then you can click on that. So you do the search system, then you do about. Uh, oh, it's already here. So and then you should be able to see the Windows system here. Like what is this Windows system specification? So that's how you check. Okay. The next one is that you need to verify that virtualization is enabled. So, and then how do you do that? Is that you can, again, so sort of very similar. You can search for Task Manager. And then once it's up, you can click on that. You can go to Performance and then the CPU. and then this one here. So virtualization should be enabled. So it should be there. Now, if it's not there, what do you call this? Depending on what do you call this, whether you own your system or not, I guess I think you need to go through the BIOS. So I'm using a work laptop, so I'm not allowed to go through the BIOS. So, but anyway, good thing that it is enabled from my end. So hopefully it is also enabled on your end, because otherwise you have to go through the BIOS, which can be a bit tricky. Okay, so check if it's enabled. It because it should be enabled or not. It the requirement of Docker is that it should be enabled. Okay. And then the next one is that you need to turn the features of the, what do you call this? Turn the features on for virtual machine platform, and then the Windows subsystem for Linux. Again, how you do that is that you can go to the search bar. What do you call this? Turn. You can just search for turn Windows features on or off, and then you can just go and click here, right? So you should, what do you call this? So where is it? Windows subsystem for Linux should be on. Oh, so there we go. So this one should be turned on, virtual machine platform, and then the Windows subsystem for Linux should also be on. So you can just turn it on by just clicking on it, and then it has a check mark. So and then if you click OK, usually it will ask you to restart your system. Otherwise, you can just manually restart your system. Okay. So, and then finally, after going through that, turning or installing the Windows subsystem for Linux, and then what do you call this? And then making sure that that you turn on the Windows subsystem for Linux as a Windows feature, and then also virtualization or as a feature, then you're able to install Docker. So what you can do is you can download Docker Desktop. So the link is here, and then you can just run the installer. So normally you just go through what do you call this? The defaults. The defaults should be fine. But if it asks you to what do you want to use? Do you want to use WSL or Hyper-V? So you should use WSL2. But normally, on systems that support only one backend, Docker Desktop automatically selects the available option for you. So there. So after the successful installation of Docker, actually before you finish the installation of Docker, it will actually ask you to restart your system. So so you can just click on that restart, and then what do you call this? And then that. So you can, what do you call this? So, and then what you can do is you can start the Docker desktop after or you restarted your system. And then you may create a Docker account or log on to your Docker account if you have it. So you may or may not. It doesn't require you to log in to a Docker account when you use Docker desktop, but usually it will ask you to create a Docker account. So, or you can, if you have Gmail, then you can just use Gmail as your account. I think that's what I did. Anyway, so now that you've installed Docker, then that's good. Okay. So now the final step, this one took me quite a while to go through to figure this out. I have to like read through the docker.com what do you call this material, and then finally, because when I try starting Docker desktop, it won't go through. um or not really, it won't go through. It would start, but it will not allow me to create containers or images. And the reason is that because as a user, I'm not in a Docker user group. So what you need to do is you need to add what do you call this? A specific user account to the Docker user group by doing this. So what you can do is you need to find out. what do you call this, the name of the account. So it's not necessarily like your email account or something like that. It should be the account that you're using in the computer. So for me, how I do it is that, again, you can just go to search, settings, and then you can just click on that. And then what do you call this? You can go to accounts, and then what do you call this? Uh, wait, I think it's this one. Oh no, that's not one. Sorry. Uh, oh no, it's already here. Sorry. So it's not this on the top. It's actually on the second line. So that is your account. Okay. Okay, let's go back. Okay. So after you find out what your account is, you can run the PowerShell as an administrator. And then what you can do is that if Docker was installed correctly, you can check by adding a user. So what you can do is you can run this net local group Docker users. What happens is that it will just list who are the accounts in your computer who uh, who are in the Docker users group. Right. Okay. So, and then if you're already there, then that's fine. If you're not there yet, what you can do is you can just use the next what do you call this? The next bullet point, that command. So it's that net local group Docker users, and then your user as as how as how you see it, and then \add, and then your what do you call this? And then your Docker user should be uh, or your account should be added to the Docker user. Now, in my system or in my computer, of course, when I add myself there, it will not add it because I'm already a member of that group. And then now you can start the Docker desktop. So there. Okay. So that's the first step. You need to go through that sort of lengthy, what do you call this? A lengthy um, procedure to install Docker. So after you install Docker and then you added yourself or you added a user yourself into the Docker user group, or yeah, Docker user, what you need to do is you need to now create the Docker file. So the Docker file is basically just a text file, is basically a text file containing a series of commands that Docker executes in order to assemble the final image. And so this is, what do you call this? This is the Docker file that I have. So this is actually what it contains. So I'll show that to you. So this one, I just open it on Notepad++. But if you open up a Notepad, what do you call this? It will still look exactly the same except for the, what do you call this? The carriage return, and then this one, the CRLF. You'll not be able to see those in Notepad. But essentially, that's it. That's the Docker file. Okay. Now let's go through what do they mean. Okay. So every Docker file must start with the from instruction. Okay, so basically this specifies the parent image you are building on top of, right? So because we are installing what do you call this, Python, or not Python, but Jupyter notebooks, we can start with a Python image. So there. So that's why it's from Python and then colon and then the version that I sort of wanted to use. Now, um, if you type that, what do you call this? So it will start with a pre-configured environment that already has Python version 3.14 on it, and all its necessary dependencies. So that's nice, right? So there are, of course, so what do you call this? I guess the advice is that use images or use parent images that are coming from the official Docker images or repository. So this is where you can find the official images of Docker. So this one is specific for Python, but so if you don't want to use 3.14, you can go and look into hub.docker.com slash, and then I think there's not a space, but a what do you, like a bar and then slash Python. So you can find out like what other Python images are available, what other versions. So, but 3.14 is the most recent one. Okay, so that's the first step. So usually start the Docker file should start with from. And then the next one is that you set the working directory to slash app. So essentially, yeah, so just here, you're just setting the working directory so that you know where, what do you call this? Yeah, so if you know, or if you specify as a working directory, then that's where all your installations will be there. So it will, what do you call this? So you sort of know where to find or look for your files. Okay. Um, yeah, because it can be quite tricky. What do you call this? Because we are in Jupyter notebooks. Later on, you'll see that it will work as a Jupyter notebook. So it can be tricky to, what do you call this? To look for like files using terminal. So that can be quite tricky. Okay. And then uh and then after that, what you can do is that you can start installing Jupyter notebooks. So run apt-get update, and then double, what do you call this, ampersand pip install dash dash no cache dir Jupyter is equal to 1.1.1. So I sort of wanted to install the Jupyter version 1.1.1. That's also the most current version of Jupyter. So let's go through the different steps. So run is basically a Docker instruction, and then basically it executes a command that is a Linux command. So yeah, so apt-get is a Linux command. So how you tell Docker to run a Linux command is by using the Docker instruction run. Okay, so apt-get update is basically what we're doing here is just we're refreshing the list of available packages from the different or from the software repositories. So we're not actually installing anything yet. We're just updating the list of available software. Okay. The logical and, or double ampersand, is basically what it means is basically it's a logical and operator. So what you can do is you can, so because what do you call this? Um, Different run commands in Docker, they are they're what they call layers. So, and then what do you call it? And then later on, we'll find out why it's sort of useful to use and the double ampersand. But essentially, what you do is that you just what do you call this? What you do is that you basically just um, run the different Linux commands all in one layer. So basically, this is apt-get update is a different is one Linux command. Pip install no cache dir Jupyter is another, what do you call this? Is another Linux command. And so for them to be executed in just a single layer, what you can do is that you can use the logical and all the double ampersand to, what do you call this, to chain your Linux commands within a layer. Okay, so pip is a standard package manager for Python. Install is basically basically what you're doing is that you're is a specific, well, it's a specific command telling pip to download and set up the software. So, and that software is Jupyter. So the no cache dir is basically a flag. So what happens here is that you prevent PIP from saving the temporary installer files inside your image. So so what happens is that because it will not save the temporary installer file, you get to make sure that your Docker image is as small as possible. Okay, and then Jupyter is a package that you want to install, and then the double equal sign followed by the version is basically the version of the package that you want to install. So essentially, you're telling Jupyter to install, or not Jupyter, but Docker to install Jupyter notebooks or Jupyter. Okay, wait, is that not? Okay, there. Um, okay, there we go. Okay. So the next one is that why do we want, you can, this will run even if you do not have, even if you end your command at Jupyter, you don't specify a version, it will still run. But why do we want to make sure that we install specific versions, or why do we want to pin versions? So one is for reproducibility. So if you build the image today and your team builds it the next month, you both get the same exact environment because you are using the same exact, what do you call this, versions. Stability, so if, for example, your code is running like last year because you're using specific versions, and then if you don't specify versions in your Docker file, what will happen is that Docker will install the most recent version, and then specific commands might be deprecated in that. What do you call this? In that package. So, and then suddenly your, what do you call this? Your codes will not work anymore because they're using different versions of, what do you call this, different versions of packages, or it may run but it may give you a different result, especially if you're doing machine learning, right? So it may give you a different result just because you're not using the same versions of the package. Okay, and then the last one is debugging, like I've said, what do you call this, or like the story that I gave you at the beginning, wherein it took me almost the entire week, just trying to go through the different codes, figuring out why the hell these are not working. But then only to find out after the week I gave up. And then I asked, what do you call this, the data scientist who gave the code to me. It's like, can you walk me through how you run this when you're debugging it? And then I noticed that, oh, she's using a different environment than I was. And this was in Databricks. So yeah, so debugging, it makes it easier to debug stuff if you're using the same versions, if you're using the exact same environment as, what do you call this, as your colleague who gave you the code. Okay, and the next one. Okay, so and then after we install Jupyter notebooks, of course, because this is our user group, we also want to use R, right? We want to install an R kernel. Actually, Jupyter stands for Julia, Python, and R. So you can also install a Julia kernel. So, but anyway, uh, we can, as a default, if you don't run the next line of code, you're fine, because your uh, Jupyter Notebook will still run, but it will only have a Python kernel in it. So you have to install the R kernel. Okay, so and then install. So this is the code. Below is the code. This one. Wait, where's my cursor? There we go. So this one over here is basically the code to install the R programming language. So essentially, we sort of do the same thing. We do apt-get install. So what do you call this? So basically, oh no, we do the up-get update. So we want to make sure that we install or we update the list of software repositories, and then because R is not a Python, what do you call this? Uh, is not Python. It will not have a PIP or the Python, what do you call this, Python package installer. So you can't use PIP install. So here you need to go apt-get install. So that's one. And then the minus Y, or yeah, not the minus Y, but the dash Y is basically a flag that says, that basically automatically answers yes to all the prompts that R will be, will be asking while you are installing this. So you want the flag to be there because normally when you create Docker files, you want this to be like in automated processes when you build the environment. So that's why you need to have the flag Y. Otherwise, it will wait for what do you call this? It will wait for you to to input uh or it yeah, it will wait for an input from you, but because these are Docker images or you want them to be automated, usually you also want to automate the answers to the prompt. Okay, so that's the dash Y. Now what okay so Okay, so this is another layer of installing R. This is one Linux command. The next one is another Linux command. This one is another Linux command. And then this one is another Linux command. So essentially, there's four Linux command in this layer. So there's the double ampersand to chain them together. And now what does the dash, or not the dash, but the slash do? So essentially the slash, so for readability of your code, especially if you're running like a lot or you're chaining a lot of what do you call this, Linux commands in a layer, what will happen is that it will so the readability becomes a little bit challenging because it will be long, so that what do you call this, so that you can introduce new lines, right? So you can do you introduce new lines. What you can do is you can do the slash so that you can do the new line. So basically the slash is a line continuation character. It tells Docker that the instruction doesn't end here, keep reading. So essentially that one. Okay, the rbase is the core R package that you want to install. You also want to install rbase dev. Remember, this is a Linux environment. So you want to, so usually when you're an R user, you just install rbase. There's like quite rare occurrences wherein you want to install rbase dev. Or because basically the rbase dev is the development package that allows you to compile R code. But usually you don't want that because there are binaries anyway. If you're using Windows. Now for Linux, usually what will happen is that you might want to install the development package for R so that you can also compile R packages from source. Okay, so that's one. Apt-get clean is basically a Linux command that what happens is that, remember, it will download the installer, and then it will install the installer, and then it will not delete the downloaded files. So what you need to do is you need to tell Linux to remove the downloaded installers, or the Debian packages. So that's what apt-get clean means. And then uh, the next line that starts with an RM is basically a cleanup step to reduce the size of your Docker image. So what it does is basically, once R starts to install, it will actually like extract what do you call this, different files, right? So it will extract different files, and then it will put them temporarily into the var lib app lists, that what do you call this, that directory. So if you do the apt get clean, it will just remove the installer, or that one big download. It will not remove the extracted files from that uh, installer. So that's why the rm command is there, so that it will remove those as well, the extracted files that you need when you were installing R. Okay, so RM basically just removes the files. The dash R is basically a flag that says delete everything inside the folders. So inside this folder, the dash F so is also another flag. So here it's just dash R and then F. It's concatenated together. So RF means for force. So it will delete um, them without asking permission. So it will force it, or showing errors if a file doesn't exist. So yeah. So again, this sort of helps you if you're in a what do you call this? In a automated process on creating what do you call this? An environment. So you don't have to what do you call this? Prompt it, or you don't need to provide prompts. And then yeah, and then the dash var, or not the dash, but slash var slash lib, that one is basically the specific location where Linux stores the temporary packages, the package indices that R uses when it runs. So that's another layer of installing the R kernel. Okay. Okay. So um, so here is the reason why we sort of want to chain our layers, not our layers, chain Linux commands in a layer. So the reason why we want to do that is that um, within the Docker environment, right? Within the layer. So when Docker creates one layer, um, if you chain them together in one layer, it will remove the junk files in that layer. Now, you can also do run multiple runs. But if you do this, like for example, this code here on top is equivalent to this one, or it looks, well, functionally, it's equivalent to this one. So it basically, what do you call this? It has the run rm, this part over here, in another layer. So even though, so it basically, it's two layers, right? So when you first run, if you run the first layer, it will include all the junk in that layer. The junk here meaning the installer, yeah, the installer for the RBase, and then also for the different, what do you call this? For the different extracted files when it tries to install RBase. Now, if you do the run rm, that one, it will actually delete the file that uses it. But then because it will delete it, but there's a hidden uh, in the history of the first layer is basically all those what do you call this? All those temporary files that are created when it tried to install, or when it was installing itself. So essentially, so it will still be uh, your image will not be as small as it can be if these are run in separate layers versus one layer, right? So essentially, the lesson here is that you want to make sure that before you proceed to the next layer, you want to make sure that your layer, you removed all the junk in that layer before you run the next layer, so that your, again, so that your image, or your contain, yeah, your image will be as small as possible. Okay. Um, Now, here's the thing. That's why I decided, when I was preparing for this talk, I decided that, oh, okay, so for the next one, I would need to be the speaker, because I didn't have time actually to include these these things here. So if you can remember, in Python, we pinned versions because it's important to pin versions because it makes it readable. It makes sure that, or it's, well, not readable but reproducible. It makes sure that we are creating the same environment every time, right? So, but however, why? But in R, why do we not have pin versions, right? So why do we not have pin versions? Now, okay, so that's where I guess Python has a little bit of an edge from R, because with Python, it has an archive of every, the PIP, right? That repository basically has every version uh, of Python packages ever made within that archive. Now, for standard Linux repositories, remember we are not using PIP when we install R. We're using Linux repositories. for Ubuntu or Debian, usually they only keep the latest version. So what happens here is that it will install the latest version all the time. So now, how do we do, what do you call this, pinning versions in R to make sure that uh, the development environment you created is exactly the same as is exactly the same every time. So I did not have time to do this, but I'll just discuss it on the next meetup. But there's a way to actually do it in R. Okay. So and then I'll just discuss it next meetup. Okay. And then what do you call this? And then here is essentially the next step is basically it installs the R kernel, yeah, so it installs the R kernel. So again, run apt-get update, we already know what that is. We apt-get install, we already know what that does. Dash Y, we already know what that does. And then the different, not R packages, but the different Linux packages that that the R kernel would use. Okay, that the R kernel would use. And then this one is that and then app get clean. We want to make sure that we remove. Oh wait, I'm not sure like if that end RM is correct. But anyway, I, I guess I just copied and pasted it. But anyway, at get clean, it will basically delete the installers that were downloaded, and then I guess the double or ampersand RM minus RF is correct, but the directory I'm not sure if this is where lib zmq3 dev and then libcurl 14 open ssl dash dev actually puts their files there. That one I'm not sure. But what do you call this? But if yeah, I guess I'll have to look that up. And then this one here, the R is basically it starts it starts R, and then basically once it starts R, the E here. So it uh this one here R starts R, and then the E is is a flag that basically says that, oh, execute everything that is in double quotes. So essentially the following string that is in double quotes. So essentially, wait, where is it? This one, install packages, IR kernel, repos, and then all those dependencies is true. So it will execute that. Okay, and then it will launch another R, and then it will perform this. Okay, this one is a uh it creates the R kernel now. So this one installs the IR kernel package so that you're able to install, or to not to install, but to create an R kernel. And then this one over here is basically creating the R kernel. Okay, so we want to be able to not be able to, but we want to identify like a package repository if you want. So that one, dependencies equal true. So that, what do you call this? What happens is that our kernel will install the different dependencies that you have. That's how we sort of use R. Um, yeah, but yeah. So it can be a little bit problematic when you're trying to pin versions because when you try to install, what do you call this? When you try to install a package and then you don't say dependencies equal to true, it will just install that package. It will not install the other dependencies. But then if so, you sort of yeah. But then if you say dependencies equal to true, it will install all the dependencies, and then you don't know what those dependencies are beforehand. So yeah, so that can be problematic in pinning versions. So how do we make sure that we pin versions in R? So that's, I guess that's included in the next meetup. Yeah. So install spec basically just registers R with your Jupyter installation, and then user equal to false basically just tells R that when you're installing the kernel, everyone should be able to use the R kernel, not just for a specific user. Okay. Okay, so now that you've installed the different layers or the different packages that you need, the last remaining ones are so the expose 888 basically tells Docker that the application inside the container is listening for connections on port 888. So 888 is basically the default port for Jupyter uh, to serve to serve its web interface. Okay, it does not open the port to outside world, meaning it does not. So meaning no one can log into your Jupyter notebook uh, outside of your laptop. No one can do that. So it will. So your Jupyter notebook, that container, is only accessible within within a, a laptop, okay, or within a system. Okay, so it does not open the Jupyter notebook outside of the, what do you call this, of the uh to the outside world, the worldwide net. So I guess the question here is that, but wait, I want to for example, if you're deploying an app, you want to make sure that, or not make sure, but you want to make sure that what do you call this, that the application or the container is accessible to where it should be accessible. So that part over there is not really the job of the data scientist. That is the job of the software development team or the network engineering team. So they may change that, right? Or so don't worry about it. So as long as you've done the containers is there, then you can just, well, at least for this one, the Docker for the Jupyter is it's a dev environment, so you can just give the commands to your colleague, and then he or she will be able to create your exact environment. So that's fine. But for like for applications or for like for example, a machine learning model that you want to deploy, what do you call this? You don't need to worry about that. That should be worried, or that should be the worry of the development team, or the software engineers or the network engineers, not the data scientist, because the data scientist part is the machine learning, right? Okay, so that's the expose 888, and then this one here, the CMD. Is basically this command below launches the Jupyter Notebook server and configures its settings so that you can access it from your web browser outside the container, but within your laptop. Okay. And then these are the different parts. The Jupyter Notebook tells a container to start the Jupyter Notebook application dash dash IP equal to 0.0.0.0.0 tells Jupyter to listen to all available network interface inside the container, allowing external traffic, uh, meaning from your laptop's browser, to reach it. And then port 888, make sure that this port 888 is equivalent to what is being exposed. No browser basically just tells Jupyter Notebook to not start a web browser because it's a container. So it should not start the web browser. And then allow root basically tells Jupyter Notebook that that yeah, run this anyway. um, and I'm run this as or allow people who are using this to run this as root. So and then it has like, I guess, just what do you call this, powerful privileges. Essentially, they can do almost anything within that container, or you're allowing people who are using your container to do anything within the container if you say allow root, but which is fine for this purpose because you're just recreating a development environment that will just lie in your laptop, wherein you're just training a machine learning model, for example. You're not deploying the machine learning. At this point in time, we're not yet deploying any machine learning model. We're just creating the development environment so that we can, what do you call this? We can train the machine learning model. Okay. Okay. So now it's just a single file. So and this is that file. over here. So essentially, you create this as a text file with all the different commands that you want to do, and then save this as. Oh well, you don't need to save this as. You can name it however you want to name it, but essentially it's a text file, and then this will be the Docker file that we will use to create the image. Okay, so now that we have created the Docker file, now it's time to create the image. Okay, so create the container image. Okay, so this is where we are at now. So there we go. So start up a Docker desktop or well, yeah, just you yeah, I think it will just be easier if you start a Docker desktop for what do you call this for um for demo purposes, but you don't need to actually. You can just I guess the most important one here is that what do you call this? You can start a terminal. But anyway, if you're working on Docker, it's also easy to just use Docker Desktop, so you can do the point and click rather than if you just open a what do you call this a PowerShell, so everything is command line, so you can't do the point and click thing. Okay, so but anyway, if you want to open a terminal, you can just click on below here, and then it will open this terminal here. Okay. Now we want to build the Docker image. So you have the Docker file here, or you already have the Docker file. So what you need to do is you need to run this in the terminal, whether it's in Docker Desktop or in PowerShell, doesn't matter. But for this purpose, it will just be in Docker Desktop, so you get familiar also with what Docker Desktop looks like. So Docker build. So this command here, just run this command, Docker build. Uh, what do you call this? Dash F is basically a flag saying that, oh, you need to use this Docker file. Okay. And then where the Docker file is. So, and then dash T is basically, oh, the Docker container or the container image that you are creating, tag it as this, right? So it's just easier to run it later if you know what the name of it is rather than a random name. Okay. Because if you don't do the dash T and then I don't, what do you call this? And then you don't put a specific name on it, what will happen is that it will get assigned a random name. So anyway, and then after that, do not forget the dot at the end. What do you call this? Basically, it just tells Docker that, oh, I am done with this command. So that's why you need to put a dot at the end. Yeah, so that's one. So if we run it, wait, sorry. Let's do this. Don't need to do that. So let's go to Docker Desktop. Okay, so if we run this command, what you can do is you can just paste the command there. And then when you run it, okay, and then it will do this. Now, this can if this is not the first time that I'm doing this, what do you call this? And I purposely and I purposely did this uh before outside of this meetup so that it will be a little bit quicker, because otherwise if you run it for the first time, this will take like 24 minutes to run, so it's a little bit what do you call this? It's it's a little bit time consuming. Okay. So now we have the image over here. Oh no, that's not it. Wait, let me just or wait, maybe I should refresh this. It's not anyway, okay. So the image was already created, or the container is already created. Wait, there's no error, right? Yeah, okay. But why is it not showing? Or did I wait, let me wait. Oh, there it is. It's on the bottom. Okay. So there's the image. So we already created the image. It says here it was created 2 days ago because yeah, I ran this 2 days ago to make sure. But anyway, it's there. If I delete this and I run this, it will take 24 minutes, so it can take quite a while. Okay. Anyway, so you've created the image now, the container image. So now the next step. Oh, wait, not that one. This one. The next step is actually to run the container image. So how we do that is that Docker run, and then we do the what do you call this? The flag P 88888 colon 8888 is basically it creates a tunnel between the physical computer and then also the virtual container, and then which uh, container image do you want to use? So, or do you want to run? And then this is the container image that I want to run. So that's why it's important to tag it so that if you tag it, then you can, what do you call this? You can specifically run uh, what the Docker image that you want. So, so if we do that, oh wait, let me copy that command. Okay, this one here. Okay, here. And then just paste the command, right click, paste the command, and then run it. Okay, so it will start the Docker container. Okay, so now once it has started the Docker container, it will give you, what do you call this? This link over here. So click on that link. That is where your Jupyter notebook is, or your Jupyter, yeah, your Jupyter notebook is, right? So this one is separate from your laptop. So it's actually in a container. Yeah, so it's in a container. So this one is, yeah, so it's separate from your laptop. So meaning its specific or its specification is not the specification of your laptop, it's a specification of what do you call this, of your Docker file, the one that you put in your Docker file. Okay, now we want to test. So the terminals are not the terminals, but the what do you call this? But the kernels are here. So and then you can also log into the terminal if you want. But then so here is the R. Oh, I already have this. Oh no, that's not it. Okay. And then to make sure that R is there, we're just going to run an R command. Uh, wait, what is, there we go. We run the R version command. So this one R dot version, and then we run it, and then there. So that's your Docker development environment that is completely separate or completely isolated from your laptop. So you don't need to worry about like, oh, what software did I install on the laptop so that it works, so that my code will work. You don't need to worry about that because if you install it in your, not install it, but if in your code you install it in, like for example, if you install it in your Docker file and or maybe in your codes when you run this, then um, it will always be there. So it will work. Okay, so it will work, but with a caveat of making sure that you're using the same versions. Now, again, just to reiterate, in R, we did not specify which versions we should be using. What do you call this? We just installed the versions that will sort of work. So very convenient if you're not developing, if you're using art, like for study or for study or for research, but not necessarily very convenient when you're trying to deploy R. So again, in the next meetup, I will be discussing that also on uh, how do you pin version packages of R. So that's it for now.